So for this problem, we were trying to decide what is the moment we need to apply to here so that the door is not going to be opened. So what we're going to do is still going to use our FBD and help us solve this problem. So we are going to draw the FBD for the door. Now let's show the forces. So A needs to find out what is the moment applied at B. At B location, since it is the pen connection, we have two reaction force. And then we are going to have a water pressure. So calculate the water pressure P is equals to the rho GH or gamma Z. Depends on what kind of unit we're having. So for this problem, we were being given the specific weight in the English units. So which means we are going to use a gamma Z to do the calculation. So now let's take a look at this equation one more time. No matter it's going to be rho G or the gamma, they are going to be constant. The only thing changed is going to be H and Z. So what is the definition of the H and Z? That's going to be the depth of the water. So what is the water pressure on the water surface? 0. So which means the Z is going to be 0. If our depths are increasing, then our pressure is going to increase too. So which means overall, we're actually going to have a triangle distributed load. So now we can see if we had triangle distributed load, what we are going to find out is what is the magnitude of this distributed load, so that we can do the simplification and then we can summarize moment around B. So what is the WF? The easiest way to do the calculation from the fluid pressure is always check the unit. This is going to be a line load. So which means what we want is going to be something that is going to be a line load unit. So for our situation, it's going to be pound over feet. So now let's do some calculation. So for the fresh water, the specific weight was 62.4 pound over feet cube. And then the depth from the water surface to the location A is going to be 9 feet. So now let's check the unit. You can see the unit are different, which means we were not done the calculation yet. We have to multiply one dimension so that the unit is going to be the same. So think about it. The door is actually going to be three-dimensional object. So which means the pressure is actually uniformly distributed on this area. We have to convert the area load to the line load so that we can set up our equilibrium equation. So which means in order to find out the magnitude of the distributed load from the water, we have to use the pressure to multiply the width of the door. In this problem, the width is 10 feet. So to calculate on another side the water pressure from the salt water, then we are going to use the pressure multiply the width of the door again. So now what we have to do is trying to simplify the load for this triangle distributed load so that we can try to summarize moment around B. So the load from the fresh water is going to be the area of this triangle, 1 over 2 base, which is 6 feet, times the height. So we do the same thing on another side to simplify the fresh water. So now what we have to do is mark the dimension. So it will be 3 feet here to the bottom here. It will be 1/3 of 6. 2 feet. Okay, so now if we try to summarize moment around B, this is the moment we want to calculate. And then we have Bx, By will be cancelled. So we had fresh water and multiply the distance from B all the way to here. So that's going to be 12 minus 3, 9 feet.